Hi everyone and welcome to this new video. In this video I want to talk about version control and Git, which is the software, the technology we use to implement version control. As always, I hope this video is useful and interesting. If you want to support my work, I would really appreciate it if you subscribe to my Patreon, where I post videos in advance and where I give you access to a private Git server with a bunch of repositories, code, certification material, and things of the sort. So if you are interested in that, check out the link in the description. Thank you very much for the support and enjoy the video. So let's introduce the idea behind version control. Why do we need version control? Now, when dealing to projects like software projects, which are medium to large, there is often the need to organize the project assets such as source code files, audio and video assets, configuration files, anything that basically represents the project, that you work with the project. So the question becomes, how do you organize these files? How do you work with these files? Now, if you simply use files and directories, which is an abstraction offered by the operating system, without anything on top, you will actually encounter many different problems, such as, here I just list a few of them, but in general, just using files and directories can be very dangerous. Now, the operating system, of course, allows us to create files and directories. That is a key primitive, a key abstraction that is offered by modern operating systems. And so your initial thought could be, okay, I have a project, let's just use some directories and some files. However, if you just use this kind of abstractions, you will actually encounter many different issues, such as the following ones, which of course, this is not a complete list, it's just a list of possible issues. For example, how can you organize two people that have to work at the same time on different part of the project? If you just have files and directories, how do you share these files and directories? How do you synchronize the changes that each person makes to the project? How can you track the specific changes that you've made or the changes that another person made? How can you revert the state of the project to some previous milestone? Let's say, for example, you have a first release, then you introduce a bug and you start to not understand anything about the project because the project behaves weirdly. You want to go back to a checkpoint, to a milestone, so that you can understand where the bug was introduced without losing everything. So how can you do that if you just have files and directories? And finally, how can you develop, for example, an experimental feature without breaking the existing project? So you have a project which is stable, the code has been tested, but now you want to experiment with it. You want to introduce a feature that you're not even sure maybe will actually stay in the final product, in the final software. So how can you just freely experiment like this and discard the changes if they don't work out, or merge them to the final artifact if they do work out? So this is exactly where version control comes in. Without version control, we'd probably have a situation where different versions of the same file are saved with a similar file name, such as app1.py, app2.py, app3.py. I mean, to everyone at the beginning of computer science, app and this kind of thing, app final, app temp, it's just a mess. You will not understand anything in the long run like this, and this is not the way you handle complex projects, but even medium projects with medium complexity becomes hard to handle them like this. So with version control instead, we have a more structured approach, more powerful approach for handling complex software projects. Now that we answer the question, why do we need version control? Let's ask the question, okay, but what is version control? Now, there are different implementations of version control, but basically all implementations share the same basic ideas and feature. You have the idea of a repository, And what is a repository? A repository contains useful metadata, which are used to implement all the features offered by version control. Now, you can imagine the following abstraction layers. We have the operating system, which of course sits on top of the hardware plus the firmware, but we won't go that deep into it. So let's assume hardware. We have the operating system. The operating system implements the abstractions of directories and files. Now, on top of these abstractions, we find the abstraction of a repository. So a repository is made up of directories and files, and it is used to implement, to contain all the metadata to handle the project. So on top of the repository, we can handle the actual project with all the extra features that are implemented within the repository. So this is basically the way you should consider what is a repository. It is like a set of files and metadata on those files that allow you to handle the project, to manage the project. Then we find the concept of a commit. Now, a commit is a record of a change to the project. It's like you can imagine a project being built commit after commit. It is like a chunk. You know, in the construction of a wall, you have the different chunks, right? The different bricks. A commit is just another brick in the wall. It's just like another step to build the project. So you can think of a commit as a snapshot of the project at a specific point in time. It is like a picture of the project. As the project evolves, as it moves, as it grows, you have these different commits. To each commit is associated an ID and a message with some other metadata, like the author of the commit. And you can view these commits in a specific log. This allows you to understand how the project evolved, basically. So we have a repository, we have commit, then we find the concept of branching. A powerful feature of version control systems is the ability to branch the project into different lines of developments known as branches. You can imagine that you start with this main branch and you develop on it. Each point is a commit. Then you can think of like, okay, now I want to develop an experimental feature. So I'm gonna branch out into the right. I'm gonna keep working on the main one just for support, stability, and things of the sort, while this extra one is being developed. While this extra one it's like developed parallelly. There is a parallel development. The branch, for example, we can call it branch dev, while this is the branch main. So the main just keeps going. The dev instead is developed to offer this experimental feature. Finally, we find the concept of merging. When a branch is finished, the end result can be merged back to the main branch, which contains the final version of the software. Now, what does it mean? It means that at some point, this dev can go back to the main, and sort of like can go back to the main branch. And in this case, there could be conflict because maybe the file you change, changed also in the main branch in the meanwhile. So you have conflicts and then you can resolve the conflicts to arrive at a final version of the software. Now, of course, these are not all the features of a version control, but are the most characteristic features of a version control. Another important aspect is the fact that, for example, the software we will see today, which is Git, it is a distributed version control system, distributed, which means that you can have a remote repository, and then this remote can be cloned into local machines. Each one can work on their own local copy, and then they can push the changes to the remote, and they can synchronize like that. So basically the idea is that it is powerful also in its capabilities to just work with a lot of different people in parallel to synchronize changes and things of the sort. So it is a very powerful way to work, and Git is used, of course, for the development of the Linux kernel, which is one of the most complex open source projects, of course. So we saw the why, we saw the what. Let's see how. How can we work with this methodology? How can we do version control? How to version control? Now, to actually start managing a project with version control, you can use one of these software. I mean, these are 3 examples, but of course here, Git, Mercurial, Subversion. Here, of course, the most important one is Git. And today in the video, we will see Git, as it is one of the most famous version control software. It was originally developed by Linus Torvalds, also the original author and current maintainer of the kernel Linux. It was developed in April 2005, and it was developed with the intention, with the main core objective of managing the Linux kernel project. Why? Because the previous software they used for version control, which was BitKeeper, was actually had a proprietary license. Meanwhile, Git was developed with open source in mind, so GPL version 2, so like very powerful software that is also open source. Now, over the years, actually, what happened is that on top of Git, which is the command line tool, which is the most basic tool to handle version control, many platforms have developed like web wrappers, web interfaces, also desktop interfaces, like many different interfaces over the command line tool. For example, we have GitHub on the web, we have GitLab, Bitbucket, Git, SourceAt, and things of the sort. So keep in mind that when you're using this platform, underneath they actually implement all the core actions, all the core commands through Git. It's just that they offer extra features, extra interfaces to manage Git repositories. But at the end of the day, we find Git. For example, if you want to support my work, I actually offer a Patreon subscription that gives access to a private Git server, which is the one that you see on the right. This is a deployment of Git, another open source wrapper over Git, and I've modified, customized for my own personal instance. And as you can see here, we find different repositories. For example, something about Bird Suite, repositories with CTFs, repositories with the various course materials, repositories for the preparation for the different certification with my .files. So basically different Git repositories. So if you're interested in that, go and check out the Patreon. Thank you very much. And actually, I want to mention about Infomaniak. Why? Because the Git server that I offer through Patreon is actually, as I said, it is a deployment of Git, and it is hosted currently on an Infomaniak VPS. This year, Infomaniak contacted me, they gave me access to a yearly VPS subscription, so I'm using their service, and so far I've had no problems. I've also contacted the support for a minor issue, and they replied me immediately. So if you're interested in hosting your own services, I can assure you that Infomaniak is a great service and you should check it out. What do? They do cloud services, web hosting, mail hosting, and things of the sort. So go and check out Infomaniak if you're interested in hosting your own services. There's actually a lot of power that comes from being able to host your own services, like I did, for example, with my Git service, and in the future, of course, I will want to host more and different services. So, at this point, we talk about the why, we talk about the what, we talk about the how. Let's see a practical example working with Git. So here I prepare the following 6 scenarios that will introduce us to the way in which we can work with the Git tool to implement version control in our project. So the way I'm going to do it is I'm just going to split the screen now, and you can see on the right the terminal. So we will see on the right the terminal and on the left the nodes. So let's start by initializing the repository. So first, of course, you must have Git installed. I can check out with which Git, I can do Git version, and my version is 2.49.0. So that's the idea. Then we want to create a folder and initialize on top of the folder the Git repository. So I'm gonna make dir, for example, my project. It could be any name. I go inside the my project directory. Now it is empty. There's no directories there, and now I do git init. I do git init, and it said, look, I initialize the empty Git repository in the folder itself. Now, if I check out once again the directories, I can see that a new .git directory has been created. This directory is used by Git to handle all the project metadata and ultimately to implement version control mechanism and features. So for example, if I go into the .git here, I see this bunch of files. If I run a tree on it, I can see, for example, I have config, description, head, hooks, info, objects, reference, and things of the sort. Now, one of the first thing we can do is actually slightly change the configuration for this repository. I'm just gonna do git config, I'm gonna do user.email, I'm gonna write xdump@mail.com. This email doesn't really work, it's just, so that I don't put my personal email there. So this is just to change the user email over the repository. If you don't do this, you're gonna get the global user email, which I don't want in this video. So basically that's the idea. And so this is how we have initialized the repository. At this point, we are ready to perform the first commit. So let's create a simple readme.md.markdown and let's just copy this content. So we have an hello world with some basic text. Hi there, this is a simple hello program in C. The point here is to learn about Git, not about C. Extremely simple. So this is our first file. Then we're going to create a source directory. And within the source directory, we're going to create a main.c file with a very simple hello world. So extremely simple. And then I'm actually going to create a make file here, make file with a simple make file. So simple make file, but let's fix the spaces here because it's a bit fucked. Okay. As you can see, this make files creates an output directory and just puts the binary in that output directory. But once again, this is not a tutorial over C or make, this is a tutorial over Git itself. So let's now, for example, see, okay, now we have these new files, right? We have the make file, the readme, the source files. What about the repository though? Because at this point in time, we have not interacted with the repository. We have just created files and directories at the level of the operating system. At this point, our objective, what will be to, okay, let's tell Git to keep track of these new files, to add these new files into the repository itself. So how do we do that? Well, first of all, we can use the command git status. Now, this command git status basically tells us, look, you are on branch main, you have not committed anything yet, and these files have not been tracked by the repository. It means that they exist at the level of the operating system, but they do not exist yet at the level of the Git repository. So how can we make them being noticed by Git? We're gonna do git add make file readme source hello. We're gonna just put everything there, source main.c. We're just gonna put git add all the files in a row. We can also do git add many different times with different files, one after the other, but in this case it's faster like this. So we do this git add. If we do git status once again, notice that now they are in green, right? They are changes to be committed. Because basically Git works with these three areas. There is the working area, there is the staging area, and then there is the commit area. Now the commit area is when everything is finalized, and the commits, as I was saying previously, they represent the actual project and how it evolved over time. The working area is just is sort of like your temporary workspace where you can create new files, remove files, modify files. You can do whatever you want there basically. And the staging area works as a sort of like middle area between the working and the commit. Before you are ready to finalize a commit, you have to move from the working area, you have to select the elements that you want to finalize, you have to move them to the staging area, and then you have to commit them to the commit area. So that's the idea. For example, in this case now, these three files have been put into the staging area. So they are ready to be committed. How do we commit them? We can do git commit, and then we can do -m for putting a message. So the message is important actually, because you want to understand what kind of changes you've made to the project. And here you can say first, because it is the first commit, add hello in C. Or like, yes, add hello in C. I mean, on this case, you could do an entire course on how to write Git commits. I myself am not the greatest at doing this, but basically the idea is that you want to be concise in the description and you want to tell, okay, what did we add in this commit? And I say, we add hello in C, hello world. So I've committed the changes, perfect. And now what's changed is that if I do, for example, git status, it's gonna say nothing to commit working tree clean. It's not gonna say anything new because everything is already committed and nothing has been modified since the committed version. If we now do git log, notice that now we do have a commit. We do have something in the repository. And this commit, it has a message, it has my name, it has my email, it has the timestamp, and it has the commit hash, which identifies the commit in the context of the repository, in the context of the project. And with that, we saw how to make our first commits. Perfect. Let's now work with multiple commits and let's showcase how we can navigate in the commit log. So to do that, we will actually have to modify the current files so that we create changes that we're gonna commit, we're gonna create further commits, and then we're gonna move in the commit log. So let's open the main.c and let's change the main function into the following one. So before it was a simple hello world. Now we're actually reading user input, we're actually reading the age of the user, and we are printing a very simple message, you entered this kind of age. Perfect. So we can of course add, we can do source add main.c basically, and then we can commit with the message read and print age. So now we have two commits, because if you do git log, look at this, we have the first commit, and then we have the second commit. And notice that on top here we find head that points to main. Now main is the branch that we are working on, the branch main, and head is the point within the log that we are actually in right now. So head is where we are at this moment in time. So that was a second commit. Let's make a third commit. So let's go into main again and let's change the function into the following one. Basically here we are just adding an extra computation, which is approximately the amount of seconds that you've lived. So here we are simply taking an approximation. Every year has 365 days, every day has 24 times 60 times 60 number of seconds, and that's our seconds. Of course, here we're not taking into account years that have less days, but whatever, it's just an approximate way, that's not the point. We'll just introduce a third change, we're gonna add it again, so we're gonna do git add once again main.c, and then we're gonna commit once again with compute number of seconds. So at this point our log is pretty rich, right? Because we have 3 commits, right? So we are starting to look like, okay, a project with many different commits. Now, an extremely cool feature of Git is that once we have multiple commits, once the project becomes complex, we can actually navigate in the history of the project. That is, we can go back in time. We can go, for example, we can ask ourselves, how was the project in the first commit? We can always go back. How do we do that? We do with the command git checkout, and then we put the hash of the commit, like in this case, E35 that ends with 02C. So we do this, it's gonna say like, now you are in a detached head state. It means basically that now, if before the commit main had 3 commits, the branch main had 3 commits, and we were at the end, now the head points actually to the beginning. So we are detached from the top of the branch, from the last commit in the branch. But we don't care about that because we just want to navigate this previous state of the project. Indeed, if we run git log, look at this, we just find the first commit. We have lost recognition of the successive commits, because imagine that we've gone back in time, and yes, technically this is where main is, but at this point we just see this one because we've gone back to this branch, to this state of the project. And what's the cool thing about it? Well, is that now we can just cut the initial program, the simple hello world. Now, let's reflect a little bit why this could be dangerous in terms of security. Why is this a problem? Why this could be a security issue? Let's say that you've committed in your branch a secret in this level, right? Secret committed. Then you realize your mistake, and in a later commit you remove the secret. Remove secret. What's the problem? The problem is that the secret actually is still readable by an attacker who gets access to the entire repository. Why? Because even though in the latest version of the project the secret is no longer there, the metadata present within the repository allows an attacker to just go back to the commit where this secret was introduced, or they can just go back to the commit before you actually remove the secret. This is why when you work, especially when you work with version control and with a Git system, and things similar to this one, you really gotta be careful about what you commit. Otherwise, you're gonna commit secrets, configuration files, environmental files, just things that could expose you to risk, to security risk. So now we've gone back, we saw this project, perfect. At this point, we can just go back to the last commit in the branch. How do we do that? We can either do git switch with this dash, and now we are back to main, we are back to the latest one, look at this, head main, or let's go back once again, we can just switch like a git switch and then the name of the branch, git switch main, and once again, we are back to that, like to the more recent commit, to the latest version of the project. And so with this, we saw how to move between commits, something extremely useful also when you have to analyze the security of a repository. Do not just focus on the latest commit, but focus also on previous commits and what developers removed, such as configuration files, API keys, and things that could still potentially work. So that's the third scenario. So let's go with the fourth scenario, which is about branching off the main branch. So let's consider now that we want to implement a branch, we want to create a branch to implement an experimental feature. So how can we do that? So basically the idea is that we're gonna first create the branch. How do we list out the different branches? We can do git branch, very simple. And here it's just gonna say main. It says main because we have no other branch whatsoever currently. So how do we create them? We do git checkout -b and then the name of the branch. In this case, it's gonna be dev, which stands for a generic development. We create and we switch to the new branch. And now if you do git branch, notice we have dev and main. Notice that dev is in green, meaning that it is the active branch, the one that we are currently working on. So let's implement this experimental feature with main here, basically. Let's go like this. So this is a new code. So how does this code work? Well, here we're gonna first enter the name, then enter the age, and then we're gonna print out our name with our age and the number of seconds that we lived so far. Pretty simple program just to showcase some kind of experimental branch. Also notice, of course, that this thing is vulnerable to a buffer overflow. This should not even be said, but you know, whatever. It's like, be careful when you use scanf because someone could put a name that is longer than 42 characters and perform binary exploitation. But this is just to showcase an experimental branch that could contain a vulnerability. So let's go back to the main things here. Let's commit this change, and let's add in the commit message, read the name. Perfect. So now if you do a git log, look at this. Now we have the first 3 commits of the main branch, and then here we say, but look, the latest one, read name, actually belongs to the dev branch. So very, very interesting. It means that we basically branched off. Meanwhile, let's go back to the, main branch, and let's just change this, and let's just remove this printf statement. Let's just remove this. So now we just did some other change. We're gonna add it, and we're gonna commit. Remove the repeated message. And then we can actually see graphically the branching as follows with this git log one line graph all decorate. So basically the idea is that we have the main branch with these 3 commits, then we branch off into dev. This is main and this is dev. We branch off into main, and here we have another commit, remove repeated message. And so this is how we branch out. We just do git checkout with the branch, with git checkout -b to create the branch, and then we just work with a new branch, and we can switch between branches with the command git switch branch name, like main, like dev, things of the sort. So let's merge those branches, right? Because now we want to merge the read name into the main branch. I mean, the feature is vulnerable, but we don't know as developers, so we're just gonna branch it. We're just gonna merge it. So first we do git checkout main. So we are already on main. We can check as follows, head main, and then we do git merge dev. So we do git merge dev. This is gonna be the merge message. I'm just gonna say merge branch dev. So I'm just gonna say that. And notice that it automatically merged the 2 code bases using the ORT strategy, which stands for ostensibly recursive twin. So basically there are different merge strategies, and merging happens when you branch out and you want to bring back the branch, what you did in the branch, into the main branch, into the main line of development. Now, the usage of branch for developing new features and things of the sort, of course, depends on how you organize internally your development process. Some big companies, they like to do everything on the main branch, so there are no branches, there are no extra branches. So once it's committed to the main single branch. Other times you have companies that like to branch out, so you have these kind of things. So in general, always be careful. In this case, actually, what it did is that it just took the content of the branch itself and just overwritten into the main. So like here, like this code was exactly the one in the branch itself. So that's how it resolved the merge. If you are not happy with the way that it resolved the merge, what we can do is we can reset the repository, which means that we can completely remove the last commit. And we can do it as follows: git reset --hard head with this caret symbol. This is just gonna nuke out the latest commit and just gonna bring us back to before we did the merge. Because after the merge, if we do this log, notice what happened here basically is that this dev branch came back into main. So there was a merging of dev into main. If we instead nuke the latest commit and we do it again, notice that we are back to the situation before the merge. And of course, if we do a git log, we don't see the merge anymore. And maybe we do this when we try to merge, but we were not happy with the result, or we committed something that was wrong. We want to reset the commit, we want to go back to the previous state. Of course, Git is extremely complex. It has a lot of edge cases, a lot of particular cases. Here, I'm just showcasing some introductory commands to help you get started, but of course, it also depends on what you want to do with the software. So continuing, we can talk about working with remote repositories. Here I'm going to showcase less commands. I'm just going to talk you through them. So a powerful feature of Git is that it allows you to work with remote repositories. And these remote repositories, you can share them with many different people. Basically, the idea you have to have in mind is that you have a remote repo on top, for example, in a VPS, remote repo, and then each single worker interacts with this remote repo in a read and write way. Sort of, you can pull the updates. So pulling means downloading the latest changes. So this is pull operation. It can push new updates, you can push new changes to the remote repository. And the cool thing is that you can handle this and it allows you to distribute the work. So this is a distributed version control system. So how do we work with remote repository? Which, by the way, is also what happens with GitHub, with GitLab, with Git. You have remote repositories that can be accessed by many different people. So to create a remote repository, what you do is you log in into your server, could be a Raspberry Pi, could be a VPS, like the one that was sponsored by Infomaniak, could be any sort of services that you have to log in remotely. You create your folder, and now when you do git init, you can do the --bear. This is going to create a bear repository, which is useful when you're working with remote repositories. It means that in a bear repository, you have no working area. I'm going to showcase very fast here. So let's create a bear repo. Let's go into bear repo, and let's do git init --bear. If I do a less here, notice that I do not have anymore the .git. Instead, all the content of the .git is actually present already in the directory, because this directory only contains metadata. There is no working area to actually work with. Why? Because this is intended to be hosted on a cloud, on a server, on something that you can then clone and then you can then work with remotely. Now, once you have a remote repository set up in some server, you can actually add such origin to an existing local repository. So this stuff up here you do on a remote server. Then on a local repository, you can add a remote as follows. What is a remote? Well, you do git remote add. You specify the name of the remote and then you specify a URL. So a way to connect to that particular repository, which is going to contain some information about the server itself and some information locally about the file system of the server, where the Git repository is exposed as a bare repository. So that's the idea. Then, for example, let's say that you put the URL wrongly. You can just set URL again. So you put set URL, the name of the origin, and the new URL there. Then you can actually read the latest changes by doing a pull operation, or you can push the latest changes by doing a push operation. And every time you pull and push, you have to specify the name of the remote, for example, origin, and also the name of the branch you're working with. So could be master, could be main, could be dev. So you have to specify also the branch that you are pulling or pushing. Now let's say that you are using a custom SSH key to establish connection to the remote. You can add this in your configuration, local core command ssh-i to the path to your SSH private key. So this one basically, that one. If you want to clone the repository, you can just do a git clone and then you put this URL, but of course you have to be able to access such URL, and therefore if you're using SSH with a custom key, you can append to the git clone the git SSH environmental command, which can specify the specific SSH command to be used for the connection. So basically the idea when you work with a remote repository is either you clone it immediately, so you have no local copy, you just download immediately the clone version, or you have a local copy and you add an origin with the command git remote add origin. So that's the two ways. And maybe in the future I can showcase more practically how to do this with remote repositories, but in this video, just to get started with Git, you can focus on the local work. Finally, configuration. You can have many different configurations. To list them out, you can do git config --list, and then you can specify specific values such as git config username xstamp, git config user.email xstamp@mail.com. And if you use the -- global flag, it's going to change this configuration across all your local repositories. If you omit the global flag, it's just going to change the configuration for that particular repository. But of course, there's lots of configuration, there's lots of things to learn about Git. This was an introduction. This video is just made to make you understand, okay, version control is a thing, this is why we use it, this is what it is, and this is how you can get started with version control. And so this is it for this video. If you have more questions about Git, write them in the comments, I will try to reply. And also, of course, there is the official documentation at git-sem.com/docs with the reference with all the different commands that you can do. I mean, there's lots of stuff with Git. I just suggest you to start very slowly with basic commands. As always, I hope this video was useful. I hope it taught you something, it made you think about something. If you want to support my work, you can subscribe to my Patreon. You can subscribe to my channel, you can spread my videos with like-minded people. I thank you very much for it and I wish you a good day and to the next video.